Okay, so this is for MEEN 1000. This is just a little Arduino example. This was from the midterm that we actually took this semester in spring of 2017. And I just wanted to solve this problem video-wise and send this out to you guys so you can use this as a reference point for how to do this. Okay, so what we're supposed to do is create this Arduino program that displays the voltage from pin A0 or A1 based on pin 8. Okay, so what does that mean? Basically, what all this stuff says is we're going to wire up a wire little jumper from 3.3 to pin A0, from 5 volts here to pin A1, and then we're going to have a jumper on pin 8. And when pin 8 is on, or when it sees high voltage, then we're going to read and display the voltage information from pin A1. Otherwise, we're going to send it from pin A0. Okay, so I happen to have Arduino right here. See if I can do this up. And this drives me bonkers, so I'll do this. So here's a nice blank sheet. Okay, so how do we do this? Well, I'm going to start right off the bat defining some of my pins. Okay, so I'm going to say int pin A for pin 1. Pin for battery 1 is equal to, now let's call it, I'm just going to call it pin 0 is equal to A0, and pin 1 is equal to A1. I'm going to say int pin 8 is equal to 8. So these are obviously pretty terrible names for general use, but they should be pretty descriptive for what I'm doing here. Okay. In setup and loop, what do I need to do? I need to have since I'm going to be printing stuff, you look here, we need to print this statement, right? So I know I'm going to be writing stuff to the screen, so serial.begin 9600 and serial.println midterm solution. Okay. Now, what are some other things that we need to do in setup? Well, again, it's one of those things that they're defaults. It may or may not make a difference, but I'm going to define the pin mode for all these things. So I'm going to say pin mode of pin 0, and this is going to be used to read stuff in. So I'm going to call this an input. Pin mode of pin 1 is an input as well. Now, this is something that I didn't expect you to do, but might as well do it. Of pin 8 is going to be an input pull-up. Because remember what input does. The problem with pin 8 is this may, when we connect a jumper from pin 8, where is it right here? I think this is it right here. If it's unplugged, is it high or low? No one knows. It's kind of one of those things that just floats around. Input pull puts a little resistor in there that makes it 5 volts and makes it on unless you ground it. So that just makes it, at least I can predict what it's going to be. Okay, so we're going through here. We did this. This. Okay. Now we need to read in the value of pin 8. So how do we read it in? So pin 8 is only good for digital read. So digital read of pin 8. Okay, but doing a digital read like that is not very helpful. I have to put it somewhere, right? So I'm going to say int p8 val is equal to digital read of pin 8. Again, pretty crappy generic name, but it should drive home the point for what we're working on. So that just did this. Now, if it is high, then read and display voltage from pin A0. If it's low, then we want to read from pin A1. Okay, so what do we need here? We need an if statement. So if P8 val is equal to 1, that's high, then what are we doing? We're going to go through and we're going to read in the pins from, so what I'm going to do is I'm going to say in pin, we'll call it bat pin is equal to pin, if it's high we want to read in, which one it is? If it's high, then from A0. So therefore we want to read this one right here. So I'm going to say pin 0. Okay. And otherwise, so I can put an else, bat pin is equal to pin 1. Okay, let's do a little gut check. So still compile. I'm going to save it as midterm, put it on my desktop. Okay, and we should be good to go. Okay, so bat pin. Oh yeah, that's a good point. So I haven't defined bat pin. So I want to define this bat pin, but I only need it local. So I'm going to say int bat pin, and I'm not going to set it to anything because I don't need to. Okay, so if it's high, so if pin 8 value, if it reads in, so put in pin 8 value by doing a digital read. If it is high, so if it's equal to 1, then the bat pin is equal to pin 0, else the bat pin is pin 1. And then we need to, so that's just telling it where to read, so now we actually need to do the read. So let's go ahead and read. So let's say our bat volt is equal to analog read of bat pin. So now it doesn't matter whether I was this one or this one. It figured out in advance which one of these to be. So I'm going to read from battery pin, but I want voltage. So remember, analog read returns an integer value between 0 and 1023. 0 corresponds with 0 volts, 1023 with 5 volts. So in order to make this a voltage, I need to multiply by 5 over 1023. The problem with this, although it's lovely and it sounds good, this analog read returns an integer, 5 is an integer, and 1023 is an integer. So this is going to return just an integer value, and we need it to be a floating point, so I'm going to do it 5.0 divided by 1023.0. So the 0.0 forces this to now be a floating point number, and the default is if you take an integer times a floating point number, it'll make a floating point divided by a floating point, and we're good to go. Okay, so the battery voltage is that. So now we've read in, we haven't displayed it yet, but we've read in from either A0 or A1 based on pin 8. Okay, so now we need to make a function called displayInfo to pass the battery number and the voltage to display our stuff. So when you come in here, we need to do something like this. We need to say, how do we create a function? Well, we already have two functions, right? Setup is a function. Void means it returns nothing. It doesn't do nothing, but it returns nothing. And this means it takes no inputs. Loop is also a function. Again, void means it returns nothing, no inputs. Well, we don't need this to return anything, so I'm going to call it void. And this needs to be display info, but we do want to send it stuff, because we're saying right here, pass the battery number and the voltage. So I'm going to call it bat num and volt. Sure. Okay, the problem with that is you have to define what types they are. And bat number is just simply going to be an integer. Volts, however, is going to be a floating point because you want it to be able to handle 1.8 or 2.7, not just 1 or 2 or 3. So there's my function. To put curly brackets. You notice I do not put a semicolon on that. That'll cause you problems. Curly brackets, and I want to display this information. So I'm going to do a serial.print. You'll notice I'm not doing a print line, and this is very important because I'm going to put together a message of a few different things. And it says the voltage of battery, oops. And now I need to know 0 or 1. Well, I pass it in right here as batnum. So I can put this. I'm going to do a serial.print batnum and serial.print is, but so I don't want to. You'll notice this is just going to return a 0 or a 1. So I want some space around there, so I'll make it look good. Is parentheses and then serial.print volt and serial.print ln. Now it would have totally worked to just put ln here, but it's kind of one of those life lessons that I end up usually adding stuff or taking away stuff from here, and so if I just put this at the end, it just makes life a little bit easier. Okay, so now we have this, and so now we need to call it. Okay, so we have this nice little function, and we need to call it. So how do we call it? Well, calling it's actually relatively simple. It's just to display info, And now I need to give it a battery number and a voltage. So the voltage I have right here, conveniently enough. So something, comma, bat volt. I don't have the battery number defined yet. So let's come in here and I'm just going to say, we can just make it a number. Bat num is equal to, if it's high, so coming in here again, right? If it is on or high, send from a 0. So this needs to be 0. And this one will then need to be 1. Okay. Fair enough. Now, if I go to compile this, you're going to find an error. I haven't defined bat num yet, so I'm going to come in here. I'm just going to define it here. Bat num. Okay, I should be able to compile this. Oops, forgot a semicolon. Kind of important. Try again. Bat volt was not described, so this is a floating point for that. Okay, oh, I forgot to update this. So now this, I need to send it bat num. And boom, there I go, it's compiled. Okay, so now you can't see it, but I'll wire up an Arduino and check it and to show you the thing. Okay, so let's compile this and put it on the Arduino. It's uploading. And let's turn this monitor on. Boom. Okay, so right now it is not plugged in, which means it is high. So it's reading from, so it's doing what this says. If it is high, then read from A0. So pin this as 3.6. Okay. And then as soon as I ground it, bonk, you'll notice it then starts reading from the other battery. If I unground it, then it goes back to high, low, high, low. Okay, so that's lovely. The only problem is right now, it's not doing this part right here. So I want to display this only every so often. So how do I display this only every so often? Well, it's this command, right? This is a command I want to call only every so often. So I'm going to come in here and I can do one more thing. I'm going to say int display, except I don't want an int, I want a long. Display time is equal to 250. Okay, so why long? Because when I use millis, real quickly you need numbers larger than what an integer has in store for it. It'll work for like a couple seconds and then it'll stop working. Okay, so when do I want to do this? I'm going to say if millis, so if the current time is greater than display time, then that's when I want to do this. I'm going to write that, oops, come back. And the display time is equal to display time plus 250. So now, run this, upload it slowly, you can do it, there we go. And now it's reading every so often. And there you go. Now, you could argue, and you can make a good argument, that to do it this way makes a little more sense, and quite frankly, I think that would be considered more accurate. It's slightly less efficient. Every time you call the millis function, it's going to take a little bit of time. The downside possibly of doing this is, say, display time is 250, and millis doesn't get there until, say, 255. Fair enough, then it's going to set display time is 250 plus 250, so it's 500. So now in theory it could be slightly less than 500, so good enough. So there you go. That is how to do that midterm test. So the only thing I could really think of, I was trying to think of what would be on the final that might be different than this. And maybe to do an analog output, right? So what if after all said and done, if we were to take this and I said, hey, you know what? Put an LED on there and have the LED be proportional to, say, the voltage that's coming in. Well, how do we do that? Let's just do that. Okay, so let's come in here. I'm going to write this. I'm going to say make LED output proportional to the read in battery voltage. I don't know if read in is the right word, but you get the point, right? So 0, if it's 0 volts, then you get 0. If it's 5 volts, then you get full bright, and so on. So how would we do this? Well, let's come in here. We're going to have to just create one more input, right? So int LED pin is equal to, now you'll notice I'm not going to put 13 because I want to do an analog right here. So I'm going to have an external LED. So let's put it on pin 3. Sure, why not? So I'm going to come in here. I'm going to do the pin mode of, if I can spell it right, of LED pin as an output, because that's definitely an output that we're doing. Okay, so we're going to come in here, we're going to do all the same thing, right? So we're going to come in, we're going to read the battery voltage. So this is where, let's do something different right here. So I'm going to say, this is actually, let's do this. I'm going to come in here and I'm going to say, you know what? The PWM, I'm going to call it int PWM val is equal to something, and so that something needs to be some function of battery voltage, right? So if we want to do a straight one-to-one comparison, we can do this. I'm going to come in above the line, and it turns out I'm going to take a temporary, I'm going to say int temp is equal to analog read bat pin, and then use this. Okay, so the reason I did that is I'm going to do a map function. I'm going to say map, and I want the inputs to be 0, and so sorry, I want to map the variable temp between 0 and 1023. Those are the inputs, and I want to map that to the outputs. So it's going to be 0 and 255. So now I'm going to end up analog write to LED pin, the PWM val. And just for giggles, let's go and actually write this out just to make sure we're not doing anything crazy. So I'm going to do serial.print ln PWM val, right? This is going to be temporary. So in the meantime, I'm going to comment this out so it's not displaying that. Okay, boom. So let's write this. And I forgot a semicolon right there. That's important. Okay, there we go, uploading. And let's look at the monitor. Okay, so right now, when it's off, we're getting a signal of 255. And if we drop that, we're getting a signal of about 185. So you'll notice, again, this is based on this voltage, right? Which is going to be read in from one of 2 pins. So the voltage is either going to be 5 volts or 3.3 volts because that is physically what we have wired up. We have it the 3.3 volt or the 5 volt. And so that makes sense that there's only ever 2 different options. But so there you go, boom, boom. So then that would be, all of a sudden you're doing an analog write right here. And it would make the LED different based on the voltage. And there you go. Let's comment this, put this back into normal, get rid of this one because that's bad form. And we are good to go. That is our code.